Let's use our calculator to find the equation of this graph, which is a translation of one of these basic functions. And let's begin by looking at x squared. So go into our y editor. X squared equals, look at that graph. I can see that's a parabola. That is not the same shape as this. This is continually increasing. This is decreasing until x is 0 and then increasing again. And we know that translations don't change the basic shape of the graph. It just will make it narrower or wider or move it around the Cartesian coordinate system. So we know it's not x squared. So let's try the next one, which is x cubed. And we can, well, that's not going to erase. Let's just clear that. Say x caret 3 is x cubed. Take a look at that. And that shape is the shape that we're looking for. But let's get a closer look at this and see what's going on. Well, it does look similar, but it seems to have moved down 2 units, and it's moved to the right 1 unit, because this is centered right at the origin, 0, 0. Here's the origin here, 0, 0. So let's look at the vertical movement first. It's gone down 2, and that represents a vertical shift of -2. The vertical is always easier because negative corresponds with down and positive corresponds with up. The horizontal is a little less intuitive because we see the graph has moved over 1, so our instinct is to add 1, but inside the parentheses we know that we actually do the opposite. So actually this is correct. X minus 2 minus 2. So this minus 2, oh, that is a mistake, isn't it? Because this only moves over 1. Let's change that to a 1. So before we press the final check button, let's go in and adjust our graph, our equation, to read the same as the one we've just input over here. X minus 1, close parentheses, then go beyond the exponent, 1 more arrow, minus 2, which is the same equation as here. Let's see what it looks like. It looks very similar. I'll enlarge this to compare. And as we said, this goes over to the right 1 and down 2 to find that center spot. This goes over 1 and down 2, and that finds that center spot. So I'm pretty confident that these equations are the same. And it is. Okay, now determine the interval of the domain over which the function is increasing. As I said, this is increasing everywhere because as x goes from left to right, we can see that the height is going in the positive direction. So it is increasing from negative infinity to positive infinity, and it's not decreasing, it's continually increasing. There is no interval of the domain over which it's decreasing. And there we go.